We are in part B of section 1.2, and we don't have much farther to go. Let's recap really quickly what you should be able to do at this point. If I give you some points, you should be able to tell me the domain and the range. If I give you some points, some pairs, you should be able to tell me if it's a function or not. If I give you an equation, you should be able to tell me if it's a function or not. And lastly, if I give you a function and then ask you to evaluate, say, f of -1, you should know how to plug in the -1 into the function. What else do we need? Well, what's nice about looking at the geometry, right? I am the type of person, maybe you're this like me. I can do, I've learned math, but if you want me to remember and to understand a concept in mathematics, I either need to see the problem, like I need to see it in an application, like a word problem, right? I need to be able to see how it would be used, or I need to be able to see the geometry of what I'm doing. If I don't have those two, then well, I don't know that I'm going to master it very well. So here's what's really nice about looking at the geometry of functions. So remember in the previous video, I kept asking the same question. I kept asking, is it a function? Right? I asked that question multiple times, and you if you were able to follow me, you could answer it. If I gave you an equation, you would be able to tell me yes or no, it's a function. If I gave you some points, yes or no, it's a function. Now, what if I give you a graph? But I ask you the same question, is it a function? Watch how easy it is to be able to tell if it's a function from the graph, from the geometry. So there's a quick test, right? We refer to it as a vertical line test. And here's how the test goes, right? Let's read the definition and do part A at the same time. So a vertical line, meaning, right? So we got a vertical line like this. And here's the idea. If you can place a vertical line, and that vertical line touches that graph more than one time, then it's not a function. I'll say that again. So notice how this vertical line touches this graph once, and there it touches it again. The same line touches the graph twice. That is enough to tell me it's not a function. So let's go ahead and do that. So I'm going to draw the vertical lines, and I'm going to say no, not a function. Right? Touches the graph more than once, the same vertical line. Now look at part B. So here, this vertical line, no matter where I put this vertical line, right? No matter where I put it, it's only going to touch that graph one time. So part B, yes, it is a function. Part C is the same thing as B. No matter, here's a vertical line, and no matter where I put that vertical line, it's only going to touch that graph one time. So yes, it is a function. D, I think you're with me. If that here's a vertical line, and it touches that graph twice. So we get to say no, it's not a function. Now, I realize that for many of you, you're good to go. All right, I told you how to use a vertical line test, and you're good to go. Take me to the next topic. And then there are some of you, right? Maybe you have a lot of math in front of you. Or you don't know if you might have a lot of math in front of you. But some of you are like me, that you want to know why. And that is powerful, okay? That is that little bit of inquisitiveness, right? We all had it when we were children. But that inquisitiveness, that if you've maintained it or you're trying to get it back, it's a beautiful thing. But here's why. This line is the input. And when it touches the graph, it's the output. So do you see how this one input gives two outputs, two different outputs? That's just like when you hit the Coca-Cola button and you could get two different types of sodas. You could get Coca-Cola or water. That's what's happening. But when it only touches, but this vertical line, one input maps to one output. That's what's happening. It's just the geometry of what's happening. Okay, so the last topic is how do we write, let me see, how do I want to phrase it? So if I give you some points, and I ask you what's the domain, well, at this stage, you should be pretty good at just saying, okay, it's going to be this, whatever number is here, and then whatever number is here. Okay, but what if I, instead of just giving you points, what if I were to ask you, take, for example, let's take this graph right here, okay? Oh, my apologies. Take this graph. What if I were to ask you the domain of this graph? Well, first off, let's you and I agree. You can't do this. You can't just write a bunch of numbers here. Because there's an infinite amount of numbers between, right? There's an infinite amount of x values from here to here. There's an infinite amount, right? That's actually, is that crazy to anyone else? That, for example, between the numbers 0 and 1, there is an infinite amount of numbers between the numbers 0 and 1. There's also an infinite amount of numbers from 0 to infinity. Quite crazy, right? All right, well, likewise, if I ask you the range between here and here, there is an infinite amount of y values. So you cannot, I'm going to go back a few pages, bear with me. You cannot do this, right? Here we could list all the y's and we could list all the x's. You can't do that if you have an infinite amount of them. So I need to teach you how to use what we call interval notation. Or or what we also call set builder notation. And I think the best way of doing that is, let's just jump in. Are you ready? Let's pretend, let's fast forward, let's pretend that a question like this is on your test, where I give you a graph like this, and I ask you to tell me what is the domain and what is the range. And for the first part, I'm only going to focus on interval notation. In fact, I would say that don't worry about set builder notation for this class. The only reason I'm even introducing it is because it might show up in your homework, and I just want you to know what they're talking about. But this is the one, okay, that I want you to focus on. So let's go through, we'll come back, I'll show you what that looks like. But let's focus on just the interval notation right now. Are you ready? The question still stands. Here's a graph. Tell me the domain. All right. So can we agree that we have been using domain? When we say domain, we have been talking about the x values. So can we agree that the graph starts here, and if I start moving along the x-axis, it stops here, right? Starts here, stops here. So I need to be able to list all of those x values, all of those x values between those two numbers. And how do I do it? Well, this is how we'll do it. So it starts at -2. Remember, please remember, I'm only looking left to right. Right? I'm only looking, when I say domain, we're looking left to right. So it starts at -2, and don't you agree with me that it stops when we get to 1? Now hold up. The question is the number -2 included? Is the number 1, is it included? In other words, does this graph actually get all the way to 1, or does it just get really close? Well, because you see how you can see these solid dots as opposed to, say, this hollow dot right here? Those solid dots are telling you that yes, the -2 is included, the 1 is included, the endpoints are included. And the way we show that is we use brackets. All right. So that bracket right there tells me that it starts at -2, and I mean -2 is included. Then it proceeds to 1, and it stops at 1, including 1. That the brackets tell me that. All right, let's do the range, and we'll go to the next problem. All right, so remember, the range is the output, the y value. So here, I need you to do this. Okay, looking at this graph, I need you to start looking up and down. I don't want you. We're not looking left to right. We're looking up and down. So I need you to tell me, if you're looking up and down, what's the smallest value y ever gets to? Well, will you agree with me that this is the smallest point on the graph? Right? And what's the y value here? Well, that's 0. The smallest, so it starts at 0 and then it goes up, right? So the smallest value of y is listed first. And then what's the largest value of y, right? You're looking up and down. What's the largest value y ever gets to? It gets to 3. Right? It doesn't go past 3. So 0 to 3. I'm using brackets because I want to include that. Ready? Let's do it again. So I'm going to do part B for you, and I really encourage you to pause the video and try part C for yourself. Okay, so let's do part B. Start off domain. Okay, we're looking left to right. So it appears that the graph starts at -3 and then starts proceeding and stops at 2. So -3 stops at 2. Now my question is the 2 included? Is the -3 included? Well, this solid dot tells me that the 2 is included. But this hollow dot tells me that -3 is not included. All that means is it gets close, it gets really close, but never actually gets to -3. All right, so we've already seen that if it is included, we use a bracket, but if it's not included, you gotta tell me that, right? You gotta tell me that it gets close but doesn't quite get to -3. We use a parenthesis. So I read this. the domain, the input starts at -3, but doesn't, not including -3, and then proceeds to 2. Now let's do range. Almost there, almost done. Let's turn our viewing point. We're now looking up and down. So I'm going to ask you, what's the smallest that y ever gets to? And what's the largest that y ever gets to? All right, well, right here is the smallest point on the graph, right? So what is that? That is 1. And here's the largest that it ever gets. What is that on the y-axis? That's over here, that's 2. So it's from 1 to 2, and back to what I was saying before, the hollow circle tells me it gets close to 1 but doesn't quite reach it, and the bracket tells me it actually does reach 2. All right, I think you should truly pause the video and try this, because if you want to know if you're getting good at this, try it. And well, I'll tell you what, let me stop talking. Pause it, try it. All right, so I'm gonna assume that you did. If you didn't, that's okay. We're still friends. Ready? Domain, I'm just gonna give you the answers. So the domain, what you should have gotten was -2 to 1. And then the range, this is tricky. I'm going to see if it got you. All right. The range is from 1 to 5. Did I get you? Did anybody get it? Or maybe, I don't know why I'm asking questions. You're not here to answer my questions. But maybe you did. Maybe you didn't. Let's look at that range. That gets students a lot. So if you're looking at range, you're looking up and down, right? What's the look at this graph. What's the smallest point on this graph? The y value right here, right? That's the lowest y ever gets to. And what's the highest it ever gets to? Right here. So that's why it's from 1 to 5. And it crosses here. It does include it. So 1 to 5. All right. We're going to conclude. The only thing I want to do is just show you set builder notation. I'm not going to spend a lot of time on this. In fact, the only reason I'm showing it to you is if it were to pop up on your homework. So let me go ahead and write this answer in set builder notation. All right, let me just make sure that I've got all my stuff in the right spot. Yeah, okay. So this is another way of stating the same thing. And in case you're like me and you're like, what the heck, what does that mean? Well, the way you would read this, okay, this is just mathematical language here, the set of x, this line right here, this line means such that, and then you would say x is within -2 to +1. Okay, so let's go ahead and conclude, and this will conclude this section, and I will see you guys in the next section.